Simplify radicals. This is a continuation from the last video. Just to remind you, in the last video we were talking about stuff like the square root of 20 and just reducing that. Instead of calling the square root of 20, we can call it the square root of 4 times 5, and that can be broken up into two separate radicals. Square root of 4 times the square root of 5, and square root of 4 is 2 because it's a perfect square, so we have 2 square root of 5. And so in the last video we learned how to simplify this radical. So instead of calling it square root of 20, we call it square root of 20, 2 times square root of 5. Something different from the last video, this is 3 times the square root of 20. So it's the same process of breaking down this radical. So we know that it equals 2 times the square root of 5. So instead of saying this is 3 times the square root of 20, we can say it's 3 times 2 times the square root of 5, which equals 6 times the square root of 5. So you've just rewritten this product to look like this, and all you're really doing is making a smaller radical. If you were to do this on a calculator, 3 times the square root of 20, you'll get the same answer as if you do 6 times the square root of 5. So you're not solving anything, you're just rewriting it in a different format. It's simplifying a radical. Another example would be 5 times the square root of 16. 16 is a perfect square. It's exactly 4, so this is really just saying 5 times 4, which is 20. So in this case, you've actually solved it, gotten rid of the radical because that was a perfect square. Another example would be like 3 times the square root of 24. So you want to try to break this into a perfect square. We know that this equals 3 times 8, but 3 is not a perfect square and 8 is not a perfect square. We also know that this equals 4 times 6, and 4 is a perfect square. So you could say 3 times radical 4 times 6. And of course, this can be broken into separate radicals. So 3 radical 4 radical 6. And this is a perfect square. It's exactly 2 times 2. So we can say the square root of 4 is 2. So we have 3 times 2 times the square root of 6. And 3 times 2 is 6. So we have 6 square root of 6. So this is the same thing as this. It's just broken down into a smaller radical. Okay, so that's simplifying radicals. And of course, this being an algebra class, we can do this with variables. Let me just first point out that if you take the square root of 5 squared, when you square 5, you get 25. When you take the square root of 25, you get 5. So these two operations sort of undo each other. This one makes it larger. 5 squared is 25, so it got bigger. And then taking the square root of 25 makes it smaller, and you end up back at 5. So these two just kind of cancel each other out. Same thing with variables. X squared, and then you take the square root, you just get x. Same thing with a cubed root. If you took 2 to the 3rd power, you'd get 8. But then you take the cubed root, you're back to 2 again. So if the root is the same as the power, then they just cancel each other out. And of course, I can do that with a variable. X cubed, and take the cubed root at the same time, you just get x. Okay, so we can do some work with variables. I want to look at the square root of x to the 4th. You could think of that as, instead of calling the x to the 4th, you could think of that as x squared squared. So you're squaring something and you're taking the square root at the same time, and so the answer is just x squared. They cancel each other out just like they did here, and you just got this term. So let me do another example like that. If I did x, the square root of x to the 6th power, you could think of that as x to the 3rd squared, because 2 times 3 is 6. So you're squaring something and you're taking the square root at the same time, you just get x to the 3rd. Of course, a shortcut to this is just to say that, you know, this is a sort of an invisible 2 here. So this is 4 divided by 2 is 2. This is 6 divided by 2 is 3. So it's always half of whatever this exponent is. So in the next example, if I did the square root of x to the 10, you'd expect the answer to be x to the 5th, which it is, because this is x to the 5th squared, and then you're taking the square root, and they cancel each other out. You just get x to the 5th. So a simpler way is just to divide by 2. What if it's an odd number? What if we had the square root of x to the 7? Well, you could think of that as x to the third squared times another x. So this would be x to the 6th times another x, which would be x to the 7th. And this right here, when you take the square root of something squared, you just get x to the third. And this x stays inside the radical because I can't take the square root of something that's not raised to the second power. Okay, so if it's an odd number, 7 divided by 2 is 3 with 1 left over. So the odd extra variable stays inside of the radical. Okay, so let's just do a couple more. Let me see. So again, if I did, x to the 11th, you would divide by 2, you'd get x to the 5th, but then there'd be 1 left over inside the radical. So that's how that looks. Now, putting all of that together, you could have something like, let me just switch up colors here, 16. So if we did this with numbers and letters at the same time, 16x to the 5th, and you took the square root of that, well, the square root of 16 is just 4. X to the 5th is like 5 divided by 2, so you'd have 2, and then there'd be 1 left over. So that's what this would look like if you simplified it. Okay, so let's do another example. 25x to the 6th, that's just square root of 25 is 5. That's a perfect square. And x to the 6th would be 6 divided by 2, so it would be x to the 3rd. That's kind of an easy one there. And two more. Square root of 20x to the 3rd. That's the same thing as, if you break this down, we need two numbers. We know that this is 2 times 10, but neither one of those is a perfect square. So we'll use 4 times 5 because 4 is a perfect square. This is x squared times x to break this in so we have an even exponent. We know the square root of 4 is 2. We know the square root of x squared is x. We cannot take the square root of 5, and we cannot take the square root of x. So this is how it breaks down. So this is the same thing as this when it's simplified. And one last example. We're running out of space here. 36p8q7. Square root of 36, that's a perfect square. It's exactly 6 times 6. P to the 8, if we divide by 2, we get p to the 4. And p to the 7, if we divide it by 2, we get q to the 3rd. And then we have 1 q left over that stays inside the radical. And that's simplifying radicals.